See what we got. Okay, so we're talking lesson 16. Da-da-da-da-dee-da-da. Okay. Consider the tables from the opening scenario. So that's this. We got the depth of free diver during descent. So S is our input and D is our output, right? So that means, hold on, let's get this right. Come on, I got stuff to do. Okay, so that means that this table right here represents a function. D equals f of s. So I have a function that is represented by this this table. S is my input, D is my output. Okay, and then conversely, right here I've got, let's see, what are we gonna call that? P equals, let's call it G. G of D. So D is my input and P is my output. Does everybody understand so far? We're just talking about these tables as functions. Yes, no? Okay. So let's hit the ground running with A. And do the tables appear to represent functions? Yeah, I just told you they did. If so, define the functions represented in each table using verbal descriptions. So let's talk about it. So the first one is the depth, right? The depth is a function of the time that they're going, that they're descending. So all they're saying there is that how deep the diver is depends on how long he's been going down, right? Does everybody understand what I mean? Yep. The depth of the diver, because he's going underwater. Obviously, we're talking divers, so we're talking underwater. The depth of the diver is how many seconds he's going down under. So if he's going down for 20 seconds, he's 15 meters below the surface of the water. And then um, the next table is talking about how much pressure there is versus the depth of the ocean. So if this dude or this lady is a diver that goes down 10 meters, they're dealing with two atmospheres of pressure. I'm not a science teacher, so I can't tell you exactly how atmospheric pressure, what exactly that means, but that's what these numbers mean. That's two atmospheres of pressure, three atmospheres of pressure, and so on and so forth. So that's what those two tables mean. Okay. So what are the domain and range of the functions? Well, that's easy. Remember, domain is the values that I can have for my input. So the domain for this first one is just 20 to 180. And then the domain for the second one is 10 to 90. Does everybody understand? Yep. And then the range is the values for your output. So my range in this case is 15 to 133. And then this one is just 2 to 10, right? Yes, no? Talking to myself? Okay. I'm talking to myself? Dang, that's messed up. Okay. Well, I guess it's okay as long as I don't answer. All right. So let's define the function in the first table as D equals f of s, which is what we said. And the second function is P equals G of D. Use function notation to represent each output and then use the appropriate table to find its value. So let's talk about it. So I want to know the depth of the diver at 80 seconds. That's our first function, right? If I know how long the diver's been going down, I can tell you what the depth is. Does everybody follow what I'm saying? That's the first chart. So that means I've got D for depth equals F of 80. That's function notation. D is the depth of the diver as a function of how much time the diver was going down. And in this case, it says at 80 seconds. So now I can look at the chart and get my answer. So what's my answer for D equals F of 80? 65. So just for those watching the video, if I look right here, here's my input of 80, and then there's my output of 65. So that's what that chart is telling me. If I have an input of 80, my answer or my output is 65. Right? Okay, so the second one says they want me to write in function notation and then solve the pressure on a diver at a depth of 60 meters. So this is P for pressure equals G of how many meters I'm below the surface. So that's P equals G of 60. So what's my answer for that? So that's P equals G of 60. And then that answer, according to our chart, like y'all said, here 60 meters down is 7 atmospheres of pressure. Does anybody question, anybody question? You show? Okay. So let's think. Explain how we could determine the pressure applied to a diver after 120 seconds of descent. So let's go back to our charts, excuse me. All right. So the question said, how could we explain how we could determine how much pressure is applied to a diver that after they spent 120 seconds going down in the water? Well, if I look at my first chart, that's about going down in the water, right? But see, my second chart is about how how much pressure I got. So how the heck am I supposed to figure out if I'm thinking in seconds to get to P? Does anybody got any ideas? How do I go from seconds from the first chart to pressure in the second chart? Nope, you don't need to divide. It's what we've been doing. Any other clues, real quick? I'm definitely not trying to put you on the spot, bro. But thank you. Okay. What we're going to do is we're going to use a composition of functions. The first function tells us the depth if we know the time, how long the person's been going down. And then the second chart tells us if we know how long the person's been going down, we can feel how much pressure they got. So what we're going to do is we're going to say P, right, equals our function. Well, no, I'm not going to say P. I'm going to say G. Sorry. I'm going to say G is our second function and F is our first function. And we're going to say if we take F, our first function of 120, it's going to give us how much depth that our diver is at. And then G says if you give us depth, we'll tell you how much pressure. Does everybody follow the logic that I'm going through? All right. So if I plug in 120 for the first function, I get an answer, and then I take that answer and then apply that to G. So what's F of 120? 160. You sure? I just want to be sure. Okay. I mean, just say yeah. Don't doubt yourself. You said it. So now I'm going to take G of 160. What is G of 160? I don't know. I'm not looking at the chart. Y'all are. It don't go that far. Oh no. Okay. So let's look. Let's look at the first chart. We said it was G of, did I say 160? Maybe that's why. What does the problem say? The problem says I said 160. No, I thought it said 120. What's the divers one we put in 120 seconds. So at 120 seconds, what's my depth? Look at the chart, man. Look at the chart, ladies. Yep. If I say at 160, I apologize because it was you plug in 120 seconds and you get 90. Does everybody see what I'm talking about? So I plug in 120 seconds and I end up with an output of 90 meters. And then I go to my second chart and I say if I plug in 90 meters as my input, How many atmospheres of pressure do I have? 10. So my first thing gives me 90 meters. And then I plug in the 90 meters here. Oh, the 90 meters here, and that gives me 10 atmospheres of pressure. So that's how I determine the pressure with just the seconds as my input, right? And we can, again, we talked about what we did for D, but they wanted us to write it, and we wrote it also. So this is function notation for that. That's function notation. And so it says describe the output. So it that's just saying the pressure that's applied to the diver after 120 seconds of descent is 10 atmospheres. That's what that's saying. Does anybody have a question on? Question on anybody? Question on? No? Okay. Um, let's look at there right now. I don't really like this one, but I'm just gonna go through it real quick anyway. Okay. So let's consider these two functions. So I've got f as a function of if I input animals, I'm going to know how many legs that animal has. For instance, if I said my input was a dog, what should my output be? Come on, y'all. It's not rocket science. 4. If I input the animal, I should get out a number of legs that they have. If I said kangaroo, 2. They have 2 legs. They kind of got 2 arms. They got 4 appendages, but we talking about legs they have. Like if I said spider, I should get what? 8. If I said ant, I should get 6. That's okay. Maybe I should have said no. Let me not say that because that'd be mean. What about frogs? If I said frog, how many legs should I get? I should get 4. So does everybody understand what's going on? Okay, so my second function, G, says if I put in Demetrius, I should get Demetrius's favorite animal. What's your favorite animal, bro? Okay, so we're gonna say dog. So if I put in Demetrius in my function, I'm supposed to get an output of dog. If I put in Abria in my function, what should I get out, Abria? What's your favorite animal? Oh, what? Oh, panda. So we're gonna say that if I put in Abria in my function G, that I'm gonna get out bear. Okay, so I get Abria, then bear. And then if I put in Ella, so Ella, what's your favorite animal? I mean, y'all just getting a little too specific. Okay. So we got another one though. If I put in Ella, I get dog. Does everybody understand? I'm afraid to ask what your favorite animal is, so we just gonna skip by that. I'm just kidding. Oh my gosh, I was gonna ask you. I was gonna. But anyway, so that's what this is saying. So now let's describe which composition of functions are defined, and if defined, describe the action. So what they're saying is, I've got a composition of functions. So I'm going to have a function with a function, or a function within a function. Is it possible to do? Okay. Well, I told you the input for f. The input for f is some type of animal. And my output is going to be some number. It's the number of legs. And then G, right, is going to be a person. And then the output is going to be their favorite animal. So can we do f of G? So that means I have f as my outer function and g as my inner function. So is that possible? Well, let's look at g. So if I got G is I got a person and I get their favorite animal. So if I plug in Danielle, sorry. If I plug in Danielle for function G, I should get out raccoon. Does everybody understand? I don't know what I mean. Y'all were like talking huskies and pandas and stuff. I guess I can't think of no generalization. I mean, a raccoon is a raccoon. But anyway, so that would be my output would be the animal. But then if I look at my function f, my input needs to be an animal, then I get out a number. Does everybody understand that if I have g inside as the inside function and f as the outside function, that works? For instance, if I said Abria, oops, let's not do Abria. Let's do Danielle. So if I said G of Danielle, or I'm just gonna say Danny because I'm old. Mathematicians were lazy, right? I don't write all that stuff. So you don't mind me calling you Danny, do you? But do you mind me calling you that? Okay. Yeah, I'm like, hey, everybody used to call me Burger, but I didn't like it then. I mean, now it don't matter, but still. Anyway, so G of Danny is going to give me 4. Does everybody understand? Yep. Because she likes the raccoons. The raccoons got. Well, dang, wait a minute. Does a raccoon have? Are those considered legs? Because I mean, raccoons be holding stuff. I don't know. That's your favorite animal, Danny. Well, yeah. So you know what? Let's go with 2. Forget that. Yep. I mean, a raccoon has they walk on them, but it's more like they. I mean, they got thumbs on they. I mean, they be grabbing stuff. So I mean, I never seen a dog grab something. So So yeah. So G of Danny is 2. Does everybody understand? Oops, I'm sorry. No, it's not G of Danny is 2. I totally got messed up. That is G of Danny is raccoon. Okay, wait a minute. Is it 2 O's too? Yeah, raccoon. So G of Danny is raccoon. Now, if I take F of raccoon, I should get 2 because they got 2 legs. Does everybody understand? Okay, just for the sake of argument, I'm gonna say my favorite animal is a spider. So I'm gonna say, and we can argue animals aren't insects, whatever. So Ferg's stuff, right? So G of Ferg is spider, and if I put F of spider, right, I get 8. Does everybody follow me? Okay, so this works. If I have F as my outer function and G as my inner function, the inputs work. G of my function, I put in a name, I get out an animal. And then for F, I put in an animal, I get a number of legs. So that one works. Does everybody follow my logic there? That I can say that this is possible. Okay? If I said F of G, that means I need to give the function a person, and then it's going to give me a number of legs of their favorite animal. That's what that does. Now, I'll just cut to the chase that these other ones are not possible. Like F of F. F is I plug in an animal, I get a number of legs. So if I said we gonna talk about F of Ella. Ella's favorite animal is what? A dog, right? And then I said F of dog, right? That's gonna give me no solution because we need to put in a person's name for F, and that's going to give us their favorite animal, right? Oh no, wait a minute. Dang, I'm totally screwing up again. F is you put in an animal and you get the number of legs. So not that. Wow. Ella is definitely not an animal. Sorry about that. Okay. What did you say that? That happens all the time? What? Okay, yeah, my fault. So let me try that again. So Ella's animal. We put in an animal. So let's put in a dog. And so f of dog is 4. So this is a function within a function. So it's f of x. right? So then that's going to be f of 4. That doesn't work because the input for my function of f is supposed to be an animal, and I'm putting in a number, so that doesn't work, so I get no solution. That's the way it's supposed to work. Does anybody got any question? So f of f does not work. G of f. So if f is my innermost function, and I plug in a person, right? I'm supposed to plug in an animal. Dang man, I'm messing up. So we're gonna plug in a Bria's what panda, or yeah, we're gonna call it a bear. So we plug in a panda, right? And I'm supposed to get was it 4 legs? Even though you can almost argue. Forget, I'm not gonna argue that. Bear got 4 legs, and we gonna call it. So that's what I get for F. And then G, I'm supposed to put in somebody's name and get their favorite animal. Well, G of 4 don't work. I'm supposed to put in a name, right? See, like G of Danny is a raccoon. G of Ferg is spider. G of Abria is a bear that lives in China. You know, so this doesn't work. That's no solution. Does everybody understand what I'm talking about? Are we all right? And you can have a function within a function within a function. I can have f of g of x. I can do that. So g of x is you put in a name, you get an animal. So I do that for the innermost function of g, I get an animal. Then I do that again, and uh, G is no, I'm sorry, I'm really messing up. So yeah, we definitely talking about Demetrius now. So we put in we put in Demetrius, and we're supposed to get dog. So for G of X, I would say Demetrius, and then I would get dog back. So then my next function is G. I would say G of dog, and it would be like, no, dog don't have no favorite animal. So nope, no solution. So this doesn't work. None of the other ones work. Does everybody follow what I'm saying? Oh my God, oh my God. Okay. So let's look at this one on page, not a clue, but number 2. Suppose a sports medicine specialist is investigating the atmospheric pressure placed on competitive free divers. Oh, isn't that what we just did? Yep, we got time of descent and then depth, and then we got depth and pressure, right? So what is, explain the meaning of G of F of 0. G of F of 0. I can help you if you want me to. What is the meaning of G of F of 0? Don't overthink it. You're probably thinking too hard. No, no. What is the meaning? Not what's the answer. Yeah, just what's the meaning? Think about what F is and think about what G is. And tell me what G of F of 0 means. Okay? I'll help you. What that means is at what is the pressure that the diver is under for if he descended or he or she descended in the water for 0 seconds. We don't our chart doesn't say anything. It'd be nothing because that's no information, right? It's not part of our chart, but that's what the meaning of that is. Yeah, again, we're not talking about what the answer is. We're just talking about what is the meaning of that. So F is a function where I figure out their depth if I know how many seconds they did. Well, 0 is my input. So 0 seconds is how long this person dived. So then what's the pressure when they dive for 0 seconds? I mean, there's nothing on our it's nothing on our whatever. So I mean, we don't really have to worry about what the answer is, but they just want to make sure that you understand what the meaning is. Okay. Um, I guess, all right. So, do I be nice to these folks that aren't here and I stop this and then shoot another video? Or do I just be like, I just start talking and talking and just have like another hour of me not doing anything, and then they have to watch this long old video for nothing. All right, so I will stop. I will stop this video, and we will continue when you get back.